Hello everyone. Today's topic is endodontic instruments that we are going to discuss. So beginning with the classification of endodontic instruments. Now how do we classify the endodontic instruments? According to the Grossman, we can classify the endodontic instruments into four categories. The first is the exploring instruments. What are the exploring instruments used for? They are used to locate the canal orifice and determine the patency of the root canal. The example of exploring instruments, they are smooth, broaches and endodontic explorer. Debriding instrument, they are used to extirpate the pulp and other foreign materials from the root canal. The example are the barb broaches. The third are the cleaning and the shaping instruments. So as the name suggests, they are used to shape the canal space. The examples would be reamers and files. So these are the reamers and the files. And the last are the obturating instruments. They are used to pack the gatta-pacha points into the root canal space. The examples are the common examples are the pluggers, spreaders and lentillospirals. Other classification, the ISO FDI classification. So the FDI, it grouped the root canal instruments according to their method of use into four groups: Group 1, Group 2, Group 3 and Group 4. What are the Group 1 instruments? The Group 1 instruments, they are hand use only. The example are the cave and the edge files, reamers, broaches. Group 2 are the latch type engine driven instruments. They are same as designed as the Group 1, but they can be attached to the handpiece. Third are the drills or reamers, latch type engine driven. Group 4 are the root canal points that we use are the gatta-pacha, silver points, and paper points. Now we can classify the instruments according to the diagnosis. They can be classified into various categories. The first are the endodontic explorer. The other is the tooth sloth. Now what is this instrument? It is instrument that is used as a fracture detector. It helps to locate the cracked teeth that normally cannot be detected. So what we see in the instrument is it have a small indentation that delivers force of bite to one cusp at a time. So it is easy to be used on the lingual cusp. So what it has a wedge tip that is designed to rest between the cusp of the posterior teeth, and we ask the patient to bite on the teeth. So when the patient bites on the tooth sloth, the plastic wedge that will push the cusp away from each other. Other is the dental transilluminator and pulp vitality tester. Now what are the instruments that are used for the access opening? We can use various types of burr like a diamond burrs, tapered fissured burrs, carbide burrs, safe and long burrs, endo Z burr. The instruments that can be used for the canal preparation, they are the barb broaches, endodontic excavators, instruments that are used for root canal preparation that can be either reamers or file. The instruments that are used for root canal obturations, number 1, the lentillospirals, spreaders, pluggers, condensers, heat carriers or thermomechanical compactors. Now let us discuss the alloys that we use for manufacturing the endodontic instruments. We can use carbon steel alloys, stainless steel alloys, nickel titanium alloys. The first are the carbon steel alloys. These contains less than 2% of the carbon. So they have a high hardness than the stainless steel. The carbon steel, they are more prone to rust and corrosion. So they cannot be re-sterilized. Example are the bar brooches. The stainless steel instruments, these are the corrosion resistance instruments. They contain 18% of chromium, 8 to 10% of nickel, and 0.12% of carbon. So that is why they have an advantage that they are corrosion resistant. Example are K file, H file reamers. So the disadvantage of the stainless steel instruments, they are stiff in nature, they are more prone to fracture, prone to distortion. The nickel titanium instruments, they contain 55% of nickel and 45% of titanium. So the advantages of these nickel titanium alloys, they have a super elasticity, they have a shape memory, they are corrosion resistant, they have low modulus of elasticity, they are softer, they are biocompatible. The disadvantage being they have poor cutting efficiency. Examples could be Nitai hand files, pro tapers, etc. Now coming to the standardization of instruments that was given by Engel and Levin. So Engel and Levin, what they found was they found a variation in the diameter and the taper for the same size of the instrument. So they suggested few guidelines for the instruments for having uniformity in the instrument diameter and the taper. So what were those guidelines? Let us discuss them. They suggested that instruments, they were numbered from 1 to 100. So there is increase in 5 units up to size 60, like 10, 15, 20, 25, 30, 35, 40, 45, 50, 55 and 60. And after 60, what you will see, there will be increase in the 10 units till they are of size 100. So after 60, there will be, the size will be 60, 70, 80, 90, 100. So each number, this number will represent the diameter of the instruments in 100 of millimeter at the tip. For example, you will see a number of 25 reamer will have 0.25 mm at the D1 and 0.57 mm at the D2. So this size will ensure a constant increase in the taper. The working blade, so this one is the working blade. It will begin at the tip D1 and extend up to 16 mm up to the shaft. This, so D2 here it should be 0.32 mm greater than the D tip. So there will be a constant taper, increase in the taper of 0.02 mm per mm of the instrument. The instrument's handle should be color coded for the easy recognition, and they are in the instruments, they will be available in the length of 21, 25, 28, 30 and 40 mm. 20 mm length we use for the molars, 25 mm for the anterior, 28 or 30 for the canines, and 40 mm for the endodontic implants. Modification from the Engel standardization. So an additional diameter measuring point at D3 is 3 mm from the tip of cutting edge of the instrument at D2, D0. Earlier it was D1 and D2 was designated as D16. The tip angle of instrument, it should be 75 degree plus minus 15 degree. So what are the color coding for endodontic instruments? Like pink color represents the number 6, gray number 8, purple 10, white 15, yellow 20, red 25, blue 30, green 35, black 40, again white 45, yellow 50, red 55, blue 60, green 70, black 80. So these color coding are important and they can be asked in your image based question as one of the questions. So with the exception of the pink, gray and the purple, all the colors are repeated every 6 instruments. Now coming to the manufacturing of the endodontic instruments. So there are two techniques by which the endodontic instruments can be manufactured, that is either through machining or grinding or twisting. The instrument in the machining part, the instrument is directly machined on the lathe. For example, H-file and Nite instruments, they are machined, whereas in the grinding, the raw wire is grounding into tapered geometric blanks, that is square, triangle or rhomboid. So these blanks, they are twisted counterclockwise to produce the cutting edges. Let us discuss the instruments. The first are the barb broaches. So these barb broaches, they are short handled instruments, primarily used for the vital pulp extraction. So they are also used to loosen the debris in the necrotic canals or to remove the paper points or cotton pellets. So the broaches, they are made from the round steel wire. The smooth surface of the wire, it is notched to form barbs bend at angle from the long axis. Remember, these broaches cannot cut dentine but can effectively be used to remove cotton or paper points that may have been lodged into the canal. These broaches should not be inserted into canal unless the canal has been enlarged to size of 25 number file. Broaches should not be forced apically into the canal, as the barbs, they can get compressed by the canal wall. So what are the function of these barb broaches? They are used to extirpate the entire pulp tissue, removal of cotton or paper points lodged into the canal, or removal of the necrotic debris into the canal. So these broaches, they can be of two types. One are the smooth broaches. The smooth broaches, they will be free of barbs. Previously it was used as a pathfinder, but at the present flexible files, they are used for this. The rasp has a similar design as that of barb broaches, except in the taper and barb size. The barb size is larger in the broaches than the rasp. Another are the reamers. The reamers, they are a K-type instruments that is used to ream the canal. It cuts by inserting into the canal, by twisting clockwise 1/4 to 1/2 turn and then withdrawing. So the motion that we will be using is the penetration, rotation and retraction. So remember, these reamers will have a triangular blank and lesser number of flutes than the files. The number of flutes in the reamer, they are 1/2 to 1 mm, but in the file the flutes are 1.5 to 2.5 mm. So the reamer have fewer number of fluids than the file. Its the cutting efficiency, it is same as that of file. The file, they are instruments that are used during the cleaning and shaping of the root canal. So the files, they are predominantly used with the filing or rasping action, in which there is little or no rotation in the root canal. It is placed in the root canal and pressure is exerted against the canal wall. An instrument is withdrawn while maintaining the pressure. So let us discuss the difference between the files and the reamer. Remember, for your exam point of view, The files, they have a square cross section, whereas the reamer, they will have a triangular cross section. The area of cross section in the files is more, the flutes are more in the files, whereas in the reamers the number of flutes, they are less. The files have lesser flexibility, whereas reamer has more flexibility. So in file what we use is the push and pull motion, whereas in reamer we use rotation and retraction motion. The file preparation shape is usually ovoid, but for the reamers the preparation shape is round. What are the commonly used files? The files commonly used are the K files, K flex files, Flexo file, Flexr file, H file, safety H file, S file. So let us discuss them one by one. The first comes is the K file. It is a triangular, square or rhomboidal in shape. It is manufactured from the stainless steel wire that is grounded into the desired shape. So it has a triangular cross section. So the disadvantage of K file, it has a less cutting efficiency. There can be extrusion of the debris periapically. Next is the K flex file. It is rhombus in cross section having two acute angles. So the K flex file, it is a rhombus in shape. It has two acute angle and two obtuse angle. So this acute angle will increase the sharpness and cutting efficiency, whereas the obtuse angle that can provide more space for the debris removal. So it is also used with filling and rasping motion. The Flexo file, it is similar to K flex file except it has a triangular cross section. So that will provide more flexibility and ability to resist fracture. So this one is the Flexo file. The tip of file is modified to non-cutting type. It has a more flexibility but lesser cutting efficiency. The triple flex file, it is made up of stainless steel and are triangular in cross section. It has more flutes than the reamer but lesser than K files. It provides better flexibility and cutting efficiency. Flexr file, it is made by removing the sharp cutting edges from the tip of instrument. The non-cutting tip enables the instruments to traverse along the canal rather than gouge into it. So that design will reduce the ledge formation. It has a triangular cross section that will improve its flexibility. So that is why we can use it in curved canals. It is made up of night eye and cuts during. Other are the H files. H files have a flute that resembles triangular sets one on another. So it is made by cutting the spiral grooves into round tapered steel wire in the same manner as the wood screws are made. So a dentist should always use the H file only in one direction, that is retraction. It should not be used in torquing motion as it tends to fracture. So when you are using it in torquing motion, the edges can engage in the dentine, so that can cause H file to fracture. The H file has positive rake angle. So since the H files, they are strong and aggressive cutter, they should be machined. They should be used in the straight canals. So the important point that you have to remember is that the dentist should use the H file in only one direction, and it should not be used in a rotational manner. Coming to the modification in the H file. The modification in the H file, they can be safety headstrom file, S file, unifile. The safety headstone file. This file has non-cutting safety side along the length of the blade. So it has a cutting as well as non-cutting side. The non-cutting side, it is directly to the side of canal where cutting is not required. So what will be the function of non-cutting side? It will prevent the lodging of the canal. Other is the S file. It is called S file because of its cross-sectional shape. The S file is produced by grinding that makes it stiffer than the H file. S file has good cutting efficiency in either filing or reaming action. So it can be classified as hybrid design. Last is the Unifile. Unifile, it is machined from the round stainless steel wire by cutting two superficial grooves that produces flutes in the double helix design. It resembles H file. It is less efficient, less prone to fracture. Next are the C plus file. C plus file, it is used for difficult and calcified canals. The C plus file, it is used for the calcified canals. It is made up of stainless steel and has a square cross section. Other is the golden medium file. It was described by Vinay. It is used for the narrow canals. Now coming to the group 2 non-rotary endodontic instruments. The engine driven instrument. The example is the gyromatic handpiece. So what are the example of engine driven instrument? It's the gyromatic handpiece. What is the speed of this gyromatic handpiece? It rotates with quarter turn motion at 3000 rpm. Why it is known as gyromatic? Because this motion, that is quarter turn to and fro, this motion resembles a steering of a ship. So that is why it is known as gyromatic. So this handpiece will use latch type of instrument. So a clinical tip: while using this engine driven reciprocating instrument, the accessibility to the apical foramen must be made with the hand instrument first. Now what are the slow speed rotary stainless steel instrument? The example is the Gates Glidden drill. The Gates Glidden drill, they have a flame shaped cutting point. Which point? It has a flame shaped cutting point on a long thin shaft. The shaft is thin, that is attached to a latch type shank. So this flame head that will cut laterally. It has a safe tip to guard against the perforation. So it has a non-cutting tip. At what size the Gates Glidden are available? They are available in set from 1 to 6 with the diameter that ranges from 0.5 to 1.5. Remember, these Gates Glidden drill, they are side cutting instrument having a safety tip. So at what speed do we use Gates Glidden drill? We use the Gates Glidden burr at the speed of 750 to 1500 rpm in a brushing stroke. The most important feature of this Gates Glidden drill is it fractures at the junction of shank and shaft of the instrument. That is the weakest part. It lies at the junction of the shank and the shaft of the instrument. If the cutting tip jams against the canal wall, the fracture will occur at the junction of the shank and the shaft, but not at the tip of the instrument. So that will make easy removal of the fracture drill. So how can you remove this Gates Glidden drill? Yes, by grasping with the pliers. Now this table is important. The number of the Gates Glidden drill, they are available from 1 to 6 size. And what is the diameter? It ranges from 0.5 to 1.5. Now what is the use of this Gates Glidden drill? The most common use of Gates Glidden drill is it is used for enlargement of root canal orifice. Second, it can be used for coronal flaring during the root canal preparation, and it can be used for the removal of lingual shoulder during the cess preparation of the anterior teeth. Remember the gates Glidden drill, it should not be used with pressure. The next are the Flexor gates. The Flexor gates, they are modified gates Glidden. They are made up of niti and they have non-cutting tip. They are more flexible and they can be used for apical preparation. The Flexor gate, they can be rotated continuously in handpiece through 360 degree. So what are the advantages of Flexor gate? They have a safe non-cutting guiding tip. It has a safety design at its breakage point is 16 mm from the tip. So once fractured, it can be easily removed. It is flexible, so it can be used in the curved canals. The next are the Piezo reamers. The Piezo reamers, they are mainly used for post-space preparation. The instruments that are used for post-space preparation are the Piezo reamer. So they have a safe-ended non-cutting tip. Their tip diameter that will vary from 0.7 to 1.7. Number 1 has diameter 0.7 at the tip, and whereas number 6 has diameter 1.7, and their primary use is they are used for the post-space preparation when the gutta pacha has to be removed from the obturated root canal. Remember these both the gates Glidden drill and the Piezo reamer, they are inflexible, so they should be used at a slow speed. Since they do not follow the canal curvature, so they may cause perforation by cutting laterally. They are stiff instrument, they have to be used very carefully. Another important classification that can be asked in your exam is Sotokova's classification. So remember it for your exam point of view. Type 1 Sotokova classification is the bent instrument. Type 2 is straightening of the twisted fluids. Type 3 is the peeling at the metal at the blade edges. Type 4 is the clockwise twist. Type 5 cracking of the instrument along the long axis, and type 6 is the full fracture of the instrument. So this question, image question can be asked in your entrance exam, like this type 4 instrument, this will represent the clockwise twist, that is the partial clockwise twist, that represents the type 4 Sotokova classification. Next comes the rotary instruments. So there are various generations of the rotary instrument. The first generation, second generation, third generation, or the fourth generation. The first generation, you will see instruments such as profiles and contact comes under first generation. The second generation is profile GT system. Third generation is K3 race pro taper system, and fourth generation is the V taper instrument. The next topic we are going to discuss is the ultrasonics in endodontics. The important point that you have to remember is the first to introduce the concept of ultrasonics in the endodontics was Richman. So there are two basic methods for ultrasound production. One is the magnetostriction and other is the piezoelectric. What is magnetostriction? The magnetostriction, it converts the electromagnetic energy into the mechanical energy. So a magnetostrictive device, it will create more of the elliptical motion that is not an ideal for the surgical or non-surgical endodontic use. Another disadvantage of the magnetostriction is that the stack will generate heat, so that will require additional or adequate cooling. Whereas the piezoelectricity, it is the process of using the crystal to convert mechanical energy into the electrical energy. The piezoelectric unit, they have some advantage with respect to earlier magnetostrictive unit as they offer more cycles per second, that is 40 versus the 24 kilohertz. The tip of these units works in linear back and forth piston-like motion that is ideal for the endodontic application. So the magnetostrictive has a vibration of 20 to 25, whereas the piezoelectric has vibration of 30 to 35. The magnetostrictive will generate heat, whereas piezoelectric will not generate heat. The magnetostrictive require cooling system by the flow of water, whereas piezoelectric does not require cooling system. The magnetostrictive is a figure of 8 motion where 4 sides are active, whereas the piezoelectric, it is like piston-like motion, back and forth motion, where 2 sides of the tip will be effective. Now coming to the physics behind the sonics. Sonic instruments, they rely on the passage of the pressure air through the instrument handpiece in order to use, operating at 3 to 6 kilohertz. The sonic instrument have a main driven that, in contrast to ultrasonic, will produce an elliptical pattern of oscillation during activation. So what are the advantages of the sonic instrument? There is a better shaping of canal when compared to the ultrasonic preparation. Due to constant irrigation, there is less chances of debris extrusion beyond the apex. It produces clean canal free of smear layers and debris. The disadvantages are chances of transportation are more in the curved canals. The wall of the prepared canals will be rough. What are the advantages of ultrasonic? The ultrasonic will clean the canal free of the smear layer and debris. The ultrasonic enhances the action of sodium hypochlorite because of increased temperature and ultrasonic energy. The disadvantages are it can cause transportation of root canal if used carelessly. Now what are the mechanism of action of this ultrasonic? It acts by 2 methods. One is the cavitation and other is the acoustic streaming. So what is cavitation? Cavitation is defined as growth and subsequent violent collapse of the small gas filled cavities pre-existing in the homogeneity in the bulk fluid. So what you will see is there will be creation of steam bubbles or expansion, contraction and distortion of the pre-existing bubbles in a liquid. So that is cavitation. Next is the acoustic streaming. The acoustic streaming will create small intense circular fluid movement around the instrument. So that is the generation of time independent, steady, unidirectional circulation of the fluid. So that results in production of large hydrodynamic shear stress around the file. What are the uses of endosonics? The use of round or taper ultrasonic has shown to produce smoother shape of the cess cavity. Ultrasonic are useful in the removal of chamber calcification. The ultrasonic instruments are useful in removal of chamber calcification. Acoustic streaming forces the irrigants together with the oscillation of the instrument. They are useful for dislodging the debris out of the canal. Low power ultrasonic can be used to vibrate the material into the position with no walls.